Hi, team. Hope your day is going well so far. We are on our next video lesson here in Chapter 7. We are going to be talking about parallel lines and proportional parts. So we're going to take a step away from our similar triangles, even though these kind of look like similar triangles in a way, but we're going to take a step away from there. All kind of similar, though. It all kind of feels the same. Okay, I'm rambling. Anywho, after today, you're going to be able to use properties of parallel lines to find missing measures. Okay, again, it's going to look real similar to what we've been doing already. So that's exciting and nice, I think. But let's just dive in. So, big idea. Here we go. It says, if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments that are proportional. There's a lot of words there, right? So let's kind of break it down. So basically what's happening is we have a triangle here, right? And then we have a line that cuts through our triangle and it's parallel to that third side. So you see those arrows there. When this situation happens, it cuts the legs of our triangle here into proportional pieces. So that's what it's saying in symbols over here. So if DE is parallel to AC, then these little pieces in here become proportional. So DB over DA is the same as BE over EC. I know there's a lot of letters and not a lot of math happening right now, so it's kind of confusing, but just kind of bear with me through this first little part. So again, if you have a line that cuts through your triangle and it's parallel to the third side, then it splits the two sides that it's going through into proportional pieces. Okay. And then the converse of that is also true. So if we flip it, so if we knew that these pieces were proportional, then we could say the lines are parallel. So I'll give you a second to jot that down. And then we can try some examples so it makes a little bit more sense. And really it should, because if you think about it, we just have two similar triangles here. Like here's a small triangle and then our big one. They both have angle B, and then we would have corresponding angles there. So then our parts would be proportional, but it won't always look like a triangle. So that's why we say it like this. Okay. So we are looking for the value of x. So here again is our picture. We have a triangle. This line or segment is cutting through it, but it's parallel to that third side. So now we can write a proportion to figure out what x would be. And there's many ways you can do this. I like to match because that's how my brain works. So I'm going to say 14. What does 14 match on the other side? Well, it matches x is equal to, now come back. Since I started on this top side, you have to come back to it. 12 over 15. And now we just cross multiply like we've been doing. So we'll have 12x, 14 times 15 is 210. And then divide out, folks. So x equals 17.5. Let's try another one. We're looking for x here. We know this whole side length's 55. We know up to here is 45. So what's left over of our 55 is 10. So I'm going to write 10 there. And now we can set up our proportion. So I'm going to have x. What does x match on my other side? Well, it matches 10. Come back to the side that x is on, which is 36. And that matches 45. And now again, we just cross multiply. So 45x equals 360. Divide out. X will be 8. Again, I don't think the math so much is so hard. It's just kind of knowing like this setup, right? I don't think cross multiplying is hard for us. It's just kind of knowing how to set it up. Okay, now we're going to see if the converse, how the converse would work. So this time we are being asked to determine if MN is parallel to JL. Okay, so we have to see if our sides are proportional in order to figure that out. So again, it's the same process, and we're just going to see if they equal out, okay? So I'm just going to start up here, 15. What does 15 match on the other side? Well, it matches 18 is equal to 4. Come back to the top, and what does 4 match? 5. And now from here, we just cross multiply. So 15 times 5 is 75. 18 times 4 is 72. Ooh, 75 equal to 72? No, it is not. That's a false statement. So that right there, kids, we would be able to say MN is not parallel to JL because we did not get the same proportion. They're not the same. Not parallel. Okay, let's try another one here. This time they give us the whole side's 54. Up to here is up to M is 24. So what's left over of our 54? Well, that would be 30. And now again, we can simply set up our proportion. So 30, what does it match on the other side? It matches 37.5 is equal to, now come back to the side with 30 on it. That matches 24 over 30. If we cross multiply, 30 times 30 is 900. 37.5 times 24 is also 900. So you see how we got the same thing, kids? 900 is obviously equal to 900, so that works out. That's true. So we now can say MN is parallel to JL. JL. Words are hard today, you guys. It's the end of the week. I just don't want to come in on Sunday because it's the Super Bowl, so I'm just trying to get it done during the school day. Not that you needed to know that, but anywho. Okay. Do you kind of understand what's going on with that theorem there? Again, big idea. We have a triangle. A line cuts through it. If it's parallel, it splits our sides into proportional parts. This next one's a little goofy. So it's talking about proportional parts and parallel lines. Okay, now really, if you were to extend these lines here, eventually they would touch and it would form a triangle. So it's kind of the same exact thing we were just doing, but we don't necessarily see the final shape of the triangle, so we're just going to call them lines. Okay? But let's read it. We'll dive into it and see what it's all about. So it says, if 3 or more parallel lines, so here would be our 3 parallel lines, these horizontal ones, right? Because those are where our little arrows are. So if we have 3 or more parallel lines and they intersect 2 other lines, so those would be the ones that are kind of making like a TP, then they cut those 2 lines, our transversals, into proportional parts. One more time. We have these 3 lines here that they are all parallel, and they're, sorry folks, intersecting these 2 transversals, these guys. And when that happens, because they are parallel, it splits all these little parts into proportional pieces. So I'll give you a second to make sure you jot that down. And then we will try some examples. They're going to look really similar to what we were just doing because it's the same idea, except we don't have a triangle now, we just have lines. Okay. So again, we're finding x, very similar to what we were just doing. Again, it's like if you were to extend these 2 lines here, oh, look, I get a triangle. So it's the same idea. We're just, we don't necessarily have a triangle in our diagram. Okay, so first things first, I know this whole chunk is 32. Let's find our missing piece there. So 32 minus 18 is 14. And now we can play our matching game. So I'm going to have 27. What does 27 match down below? It matches 18. X matches 14. And now again, it's the same problem we were just doing, right? We can cross multiply. So we'll have 18x. 27 times 14 gives us 378. Then we divide out. 378 divided by 18 is 21. Perfect. All right. Our next one, same type of problem here, just a little more algebra involved. So I'm going to write 2x plus 2. What does that match on the right side? X plus 3 is equal to, come back to that left side, 21. What does 21 match? It matches 12. All right, now we're going to cross multiply, but since I don't just have one term here, I have two terms. We have to distribute, right? So I'm just going to put it in parentheses just so I remember to distribute to both things. Perfect. So now I'm going to distribute here. I'll get 24x plus 24 is equal to 21x plus 63. Bring our x's to one side, our numbers to the other. I'm going to do that in one step. I hope that's okay with you. So we should have 3x equals 39. Then divide out, x should be 13. Okay, switching gears once again. We have a triangle mid-segment, and the mid-segment is similar to that of the trapezoid mid-segment that we had last chapter. The name kind of describes it, right? It's the middle of your triangle. It's the segment that goes through the middle, right? So if we fill in the blanks here, a mid-segment of a triangle is a segment that connects the midpoints of the two sides of a triangle. In this example here, it is DE. And how do I know D is the midpoint of AB? Remember, those tick marks are telling me, and those tick marks here are telling me that E is the midpoint of BC. And it's we're able to find the measure of this, okay? So it says if a segment joins the midpoints of two sides of a triangle, then the segment is parallel to that third side. So DE is now parallel to AC, and it's half as long, which kind of makes sense. If it's in the middle, it should be about halfway, half C's, right? So now this is just reiterating what we just talked about. So in our picture here, DE is parallel to AC. And if I wanted to figure out the length of our midsegment DE, it's half of AC. Okay, let's finish up by trying some examples with a midsegment, okay? All right. Kind of a lot going on in this picture, but that's okay. It says if LM and N are midpoints of the sides of our triangle PQR, okay? So these guys are equal, those two are equal. Just know that these are all my midpoints. And then we're told PR, this whole side over here, is 46. PQ, this whole side is 40. And LN, this little guy in here, is 17. Now let's fill out what they are asking us to solve for. LM. Okay, folks, you see LM here? What side is LM parallel to? Well, it's parallel to PR. So it's going to be half as long. So what is half of 46? It's 23, right? So this guy's 23. Okay, MN. MN is right here. MN is parallel to this side of my triangle PQ. So it's going to be half as long as PQ. So what's half of 40? Half of 40 we know is 20. Ooh, we're looking for QR. We don't know what QR is. However, we do know that our midsegment LN is parallel to that side. So remember, this is half as long as QR, so we can double it. So 17 times 2 is 34. Then our last one here, so we just found that this is 34. They are asking us to find MR, so half of 34 oops, is 17. Good work. That was a fun one. And then our last one, just to practice on algebra, because that never goes away, right? We're looking for the value of x. We have a mid-segment here because I have these tick marks telling me those are the midpoints. So remember, in order to find this length, it's half this. Well, I don't like working with fractions, so I'm going to double this and set it equal to my side of my triangle. So I'm going to have 2 times 7x is equal to 17x minus 18. Distribute that 2. Subtract over my 17x. It's okay that we get a negative variable because it won't be that way for long. Divide out. She gets 6. Are we okay with that? I hope so. Thank you for tuning in. I hope you have a super rest of your day. And as always, I really appreciate that you have made it this far in the video and took notes. Okay, until next time, kids, have a good one.